everyone. Today we're going to talk about how to find overlapping and non-overlapping values from two different data sources using dplyr. This is going to build upon the same dataset on white ratings that we've used in previous videos. If we wanted to find out which rows appear in both the selected countries list and this top list, the global top list, we can do, like I mentioned, an intersect function and pass the two vectors in. And let's check out who the winners are. So these 10 countries are both in the top list and the selected country list. So if you want to further refine the top list and select only the top, let's do 10 again, contenders. We'll override this top object and only select the first 10 entries. So if we examine the top object again, here are only, the ones that still remain. And let's do the intersect function again. And check out this variable. Oh, oops, sorry. We should have done top instead of both. We see that only 3 countries appear both on the top 10 producing list and the top 10 global best list. So next time you go shopping, pay attention to French, Austrian, and Australia wines. As a complement to intersect, we can find out which observations are not in both lists. So in other words, which entries only appear in one of the lists. You do setdiff, which is now searching for variables that don't belong to both lists. So here we could have probably guessed that it would be the remaining 7 countries, but I typed out the syntax just so you can see clearly what I meant here. So these 7 countries are in the top 10 producing countries, or rather, they are not in the top 10 producing countries list, but they do produce high quality wines nonetheless. So after dissecting this data frame from a country perspective, we can now turn to focusing more on the grapes. So in other words, if you want to find out which are the most represented grape varietals in this data set, we can do something as follows. Let's say top wine, creating a new object again, starting from all the way from the original data set wine, and do another group by aggregation. This time we're gonna group by variety over here instead of country. And then summarize as usual. I know I did count as my new count variable before, so just to switch it up, I'm gonna use the word number now and doing the exact same thing. Another pipe operator and a range function. Again, I want to set it to descending order since I want to find out, I want the largest value to appear on top. And then I'm selecting the top, say, 10 grapes. Oh, looks like there's a typo. There we go. Let's check out this variable. It's, again, another data frame, and I want to set it to a vector. So let's do something like this to override this object. And now it's a character vector. So these are the top 10 most represented grape varietals in this data set. If we want to find out which varietals tend to be higher rated than others, we can, again, with the help of ggplot, visualize this pretty easily. We're gonna do another filter from dplyr. and use the same syntax and filter for rows that have values of variety only in the top wine list that we just created, and do another group by summarize. I'm gonna call this median again, but I could name it anything I like. And you see that ggplot works seamlessly with the pipe operator syntax in dplyr. So here I'm passing it directly after all the other functions. And again, each function takes the variable immediately preceding it as the argument. So it's like waterfall structure, so to speak. So here I want to order my x-axis, which is going to be variety, but we want to make sure that the order is dictated by the median of the median variable. Don't be confused here. I'm going to do a geom call function, just make sure this is it's going to be column structure, simply counting how many observations appear in each category. I'm going to fill it by variety, also adding some labels and title. Let's say variety and median point is a straightforward label. Since there are some grape names that are longer, for example, Sauvignon Blanc, Bordeaux style, red blend, they're not going to all appear on the graph on the x-axis, so I'm gonna say abbreviate the x-axis. And because it is a discrete variable, I'm spelling that out here. It's a scale x discrete and pretty straightforward. And the labels are going to be abbreviated. Let's see what this gives us. So not a huge dispersion here, but then again, one big caveat when working with this set is that all the wines were already pre-selected and they were all rated above 80. But we do see that Bordeaux style red blend tends to be the highest rated grape, followed by Pinot Noir and Syrah, so on and so forth. Finally, if you're a savvy consumer, not just a curious enophile, you might want to know where the best values are. So in other words, if you want to find bottles of wine that are of as high quality as possible, but don't cost that much, we can do another intersect function and find the rows that appear on the top, towards the top, on the ranking list, but appear towards the lower end of things on the price list. So let's do that now. Let's say we want to find out the top 15% of all wines in terms of ranking. You should know by heart how to do this now. Making sure it's going to be descending order according to the points variable. Going to filter. Since we're selecting the top 15%, the probability in the quantile function is going to be 0.85. So we're saying that we want the observations that have a value higher than 85% of the whole set. So in other words, we're filtering for the top 15%. There we have it. Now we're gonna find the cheapest 15%. Now we arrange by price instead of points. When we do an intersect, we want to make sure that our two data frames have the same numbers of rows. And without looking at how many rows there are in my top 15p object that I just created, I'm just gonna say for the cheap 15% object, I want to select however many rows there are in my other data frame. So instead of the top underscore and syntax, I'm now using the head function, which achieves a similar goal, but instead of explicitly passing a number, I'm now saying that I want to find however many rows there are in this other data set. So there we have it. And finally, we want to know where all the good value ones are. So let's do an intersect function and pass the two new data frames that I just created. There we go. And if we want to examine this object, let's just call it. So there you go. Looks like we have 16 bottles that come from Portugal, France, US, Italy, and Austria that are among the top 15% in terms of rating and the bottom 15% in terms of price. So get more bang for your buck, so to speak. Next time you go shopping, you know where to look for good values of wine. I might actually put these on my personal shopping list before I go to the store. That's it for our tutorial today. There are many other things dplyr can do, but I think the most important takeaway for today's video is that group by aggregation or group by summarize functions used as a combo is a great way to slice and dice a data set. And it really provides a lot of insight into whatever data you have. In the next video, we're going to talk about how to do feature engineering using dplyr, including how to create new columns based on existing features in a dataset. We'll also learn different ways to join datasets, including full join, inner join, left join, and right join. Thank you for watching today's video, and see you next time.